Here's the primary governor in its overspeed condition state. Entering the bottom of the governor is our engine oil. Okay, our engine oil can run anywhere from 40 to 90 psi. It comes up and over to our high pressure oil pump, which converts it to 385 psi, and then it enters into the different cavities of the governor. We have our beta valve right here. We have our pilot valve right here, and our relief valve, our feeder spring that is above our counter flyweight right here. So these spin around, and the pressure, they're going to push up on the spring as we push our prop lever forward. It's going to let the spring pull up on the spring. We have pneumatic pressure from the FCU, PY pressure, entering the top left side. We have our bleed air link, minimum governor adjustment, and our max stop adjustment. Okay. In green is our high pressure oil, okay, that comes to and from the servo. Okay, remember we talked about that they were going to call this servo in the near future of the presentation. So our servo, remember, is shiny stainless steel cylinder in front of the propeller, and inside it has a piston that goes back and forth. As the piston goes back towards the hub, it's going to push oil back from the servo into the governor, and when there needs to be more pressure in the servo, it's this pilot valve here is going to open up and allow pressure to go to the servo, or the piston and the cylinder. Okay, so the propeller governor consists of mechanical governor and a beta valve and pneumatic PY pressure. Okay, if this were in our underspeed condition, the RPM would fall below the prescribed setting or has not reached the selected speed. The on-speed condition is when engine, propeller, and propeller governor are all at a state of bounce. Okay, so everything will be equal. Our overspeed condition, which is what we have here in this pneumatic schematic. An overspeed condition will occur when the propeller RPM is driven above the prescribed speed. So right now this is a picture of it being above the prescribed speed. In the feathering position, the governor pilot valve, okay, that's this one right here, is raised mechanically to decrease the oil pressure in the propeller. Okay, so when this valve is raised, it will decrease oil pressure that goes to the propeller. Okay, the beta range is oil pressure to and from the propeller is metered by the beta control valve through the mechanical lever and the feedback ring. Okay, so remember there's a lever that hooks to the end of the beta valve that goes to the, draw a little feedback ring. Okay, so these two are connected, and so wherever this feedback ring is positioned, forward or back, that's going to move this beta valve in and out. The picture of this next schematic we have is the governor and propeller in cruise configuration. Okay, so here we have the propeller, and the propeller is full of high pressure oil, okay, keeping the blades at a particular angle. Governor is working towards that objective of keeping a constant speed on the propeller. Under normal flight conditions, the governor acts as a constant speed unit and maintains the propeller speed selected by the pilot by varying the blade pitch to match the load to engine torque in response to changing flight conditions. Overspeed prop governor right here. It's mounted on the top left side of the engine. During normal forward thrust operation, the NF governor, which is this section right here, okay, this is the NF governing portion of the fuel governor, okay, where the PY pressure goes in. Protects the engine against possible power turbine overspeed in the event that the propeller fails. The beta valve and the push-pull control that comes from the control cam just forward of the FCU. Okay, so back here we have the prop governor, the cam assembly, and the FCU locations on the engine. The propeller is only going to operate between 1600 and it should be regulated at its maximum stop at 1900 RPM. Anything below 1600, basically the propeller is just going to be spinning out there in front of the airplane in low pitch position until you get above 1600, and then it'll start governing. This picture of the schematics of the governor is in the feathered position. When the propeller control is placed in the feathered position, the pilot valve right here, a pilot valve, is raised mechanically to decrease the oil pressure at the propeller. Under the influence of the return springs and counterweights, the blades are rotated to the feathered position. Okay, so in the feathered position, we have low pressure oil, high pressure oil, and then the pilot valve raises mechanically because of the position of the pilot inputting the cable control on this lever, and so that would make the pilot valve raise up. The picture of this schematic is in the full reverse position. In the full reverse position, the piston inside the cylinder or the servo is going to be extended all the way forward. And then also at this point, the beta valve acts as a hydraulic fine pitch stop for the propeller, maintaining a given propeller fine blade angle, such as during descent. The hydraulic fine pitch stop is also the origin of the beta range, and it will continue to control the blade angle through the maximum reverse blade angle. Low blade angles and reverse angles are scheduled by the cam box and cable arrangement that is connected to the propeller lever. Movement of the power lever into the beta range moves the cam cluster and levers such that the complete integration of the propeller blades angles and power application is achieved. There has to be perfect rigging between the throttle quadrant and the front of the engine.
Relax, calm down now. Don't stress. Take it easy.
Okay, I apologize if this seemed like kind of a boring subject, but it's something we need to cover. You probably won't remember it past the time it takes you to take the test, But here we're at the overspeed governor, which is right here. We have the solenoid to the overspeed governor. This switch is actually in the cockpit on the left hand side. We have the primary governor, we have the propeller, we have the shaft, the engine shaft. Okay, so the overspeed governor is set at 104% MP, which converts to 1976 RPM. The governor in its overspeed condition will think that it's at 1976 RPM. When the engine overspeed condition occurs, the increase in centrifugal force sensed by the overweights overcomes the spring tension. So these centrifugal of the counterweights will overcome the spring tension, allowing this pilot valve to lift up, and when it lifts up, it's going to dump oil back out of the primary governor and onto the shaft of the engine. This permits the combined forces of the counterweights and return springs to move the blades towards a coarse pitch position, absorbing the engine power. The solenoid valve, which resets the governor to a value below its normal overspeed setting, is provided to permit ground testing of the unit. During testing, the overspeed governor is reset at 1750 RPM plus or minus 60. So once we press and hold this solenoid from the cockpit, it's going to bring back the RPM to 1750 plus or minus 60. And if it does that, the unit's working. The maximum RPM should be 1900, and the pneumatic minimum adjustment can be used to adjust the NF governor minimum setting by 5% plus or minus 1, okay, which is right here. The symptoms that you would have before you would need to make the adjustment here would be your blade angle would be fluctuations at high RPM. So to do that, you're going to disconnect this arm, tie the arm back this way, okay? So you're going to want to pull it this way and tie it. Then you're going to want to run up and adjust to 4 to 5 below selected 1900 RPM, which would be 1805 RPM. This procedure keeps the beta valve and the pneumatic from fighting against each other. So that's the only time you'd want to make that adjustment. One thing I would do, instead of disconnecting the rod end, when you change prop governors or fuel controls or any other item that has a rod end and a push-pull control on it, is leave your levers attached to the rod end and pull your lever off your control rather than attach your rod end and your control. It's what this does is the shortcut is that you push your power lever or propeller lever, condition lever, wherever you want it, and so it's hitting the stop, and then you just slip it right onto the shaft. It'll save you a little bit of time. And I hope with that you have received the knowledge and familiarization with the prop that's installed on the caravan.